What if I told you that humanity's most powerful eye on the cosmos, the James Webb Space Telescope, teamed up with the almost supernatural intelligence of Google's quantum computers, has just glimpsed something that screams, yes, to that very question? Something that suggests the universe you perceive is merely the surface layer of an infinitely more complex, multi-dimensional existence. This isn't science fiction. This is the bleeding edge of discovery, and it's about to make you question everything you thought you knew. Are you prepared to peer into the abyss, and perhaps, just perhaps, find the universe and yourself staring back in a whole new light? Let's set the stage. Our leading star in this cosmic drama is none other than the James Webb Space Telescope, JWST. Forget what you know about its predecessor, Hubble. As incredible as Hubble was, Webb is a different beast entirely. Think of Hubble as having incredible eyesight for visible light, like ours. Webb, on the other hand, sees in infrared. This is crucial because the universe is expanding, and light from the most distant ancient objects gets stretched out, shifting from visible light into the infrared spectrum by the time it reaches us. A phenomenon called redshift. Moreover, vast clouds of cosmic dust, opaque to visible light, are like translucent curtains to Webb's infrared gaze. It's like having X-ray vision for the cosmos, allowing us to see the universe's baby pictures, galaxies forming when existence itself was just a toddler, a mere few 100 million years old. Now, picture this magnificent instrument turning its golden eye towards a particularly fascinating patch of sky, Abell 2744. Astronomers affectionately nicknamed it Pandora's cluster, and for good reason. It's a colossal pileup of at least 4 smaller galaxy clusters, all crashing together in a slow-motion cosmic ballet spanning billions of years. This chaotic, beautiful mess is a treasure trove for astronomers, especially because its immense gravity acts as a natural magnifying glass, a phenomenon called gravitational lensing, allowing us to see even more distant objects behind it. Webb captured images of Pandora's cluster with a clarity that was breathtaking, revealing intricate details and ancient galaxies no human eye had ever witnessed. Astronomers were ecstatic, poring over the data, cataloging new finds. But here's where our story takes an electrifying turn. It wasn't an astronomer squinting at a screen who first flagged something truly peculiar. It was a team from Google, wielding the almost mystical power of quantum computing. Traditional computers, even supercomputers, process information sequentially, like a meticulous librarian checking out one book at a time. Quantum computers? They're like a librarian who can simultaneously read every book in an infinitely vast library, explore every possible storyline, and see connections invisible to the linear mind. These Google wizards had developed algorithms specifically designed to sift through colossal datasets, looking for patterns, for anomalies that defy conventional explanation. They fed Webb's pristine images of Pandora's cluster into their quantum systems. And what came out? Not just beautifully resolved galaxies, but subtle, almost imperceptible distortions in the light patterns, particularly in the way gravity from the cluster seemed to be bending the light from background objects. These were not the expected, well-understood effects of gravitational lensing. These were different. Imagine you're a master art restorer, examining a centuries-old masterpiece. You know every brush stroke, every layer of varnish. Suddenly, under a special light, you detect faint, underlying strokes that don't match the artist's known style or even the pigments available in that era. Or, to use the article's analogy, you're driving with a flawless GPS, and the road ahead suddenly veers off in a direction the map insists doesn't exist. These light patterns, these quantum-level quirks detected in the infrared whispers from deep space, were precisely that, a deviation from the established map of physics. They were tiny, almost ghostly signatures that standard cosmological models The physics we've relied on for over a century simply couldn't account for. These weren't just pretty pictures anymore. They were breadcrumbs leading us down a rabbit hole, hinting at something utterly profound: the possibility of dimensions beyond our familiar 3 of space and 1 of time. Why should this celestial detective story matter to you, sitting there, perhaps sipping your coffee? Because the universe isn't some abstract concept confined to textbooks and laboratories. It's the grand theater in which your life, my life, all life unfolds. Every subatomic particle that constitutes your being, every thought that sparks in your mind, every breath that sustains you, is woven from the very fabric of this cosmos. If that fabric has hidden folds, unseen dimensions shaping its structure and behavior, then they are, in some fundamental way, shaping you too. This isn't just about understanding distant galaxies. It's about understanding the deepest nature of our shared reality. Enter the quantum computing team from Google, our digital Sherlocks in this cosmic enigma. As we touched on, their tools are revolutionary. While a classical computer bit is either a 0 or a 1, a quantum bit, or qubit, can be a 0, a 1, or both simultaneously, thanks to a principle called superposition. And through another quantum phenomenon called entanglement, qubits can be linked, their fates intertwined regardless of distance. This allows quantum computers to explore a vast number of possibilities exponentially faster than any classical computer. Think of trying to find a specific grain of sand on a beach. A classical computer would check each grain one by one. A quantum computer could, in a sense, check all of them at once. When this powerful analytical capability was unleashed on Webb's data from Abell 2744, the quantum algorithms began to isolate these peculiar light distortions. They weren't random noise. They exhibited a consistent mathematical signature. And here's the kicker. These mathematical signatures bore an uncanny resemblance to predictions made by one of the most ambitious and often controversial theories in physics, string theory. For those not yet initiated into this cosmic concert, string theory proposes a radical reimagining of the fundamental constituents of our universe. It suggests that if you could zoom in on an electron or a quark closer than ever thought possible, you wouldn't find a dimensionless point. Instead, you'd find a tiny, vibrating filament of energy, a string. Just like the strings on a violin or a guitar can vibrate at different frequencies to produce different musical notes. These fundamental strings, vibrating in different patterns, manifest as the different particles and forces we observe. An electron is one note, a photon, another, a quark, yet another. It's an elegant vision. The universe as a grand cosmic symphony. But here's the catch. The part that has often made string theory seem like pure mathematical fantasy. For the equations to work, for the symphony to play in tune, the universe can't just have the 3 spatial dimensions, length, width, height, and one time dimension we experience. It needs more. Most versions of string theory require at least 10, sometimes 11 spatial dimensions. So, where are these extra dimensions? The prevailing idea is that they are compactified, curled up on themselves at an infinitesimally small scale, far smaller than an atom, perhaps as small as the Planck length, which is the smallest possible measurable distance in the universe. The classic analogy, as mentioned in the article, is the garden hose. From a great distance, a long garden hose looks like a one-dimensional line. You can only describe a point on it by its length along the hose. But as you get closer, you realize it has a second dimension, its circumference. An ant walking on. The hose experiences both dimensions. It can walk along its length or around its circumference. These extra dimensions, string theorists propose, are like that tiny circumference, curled up so tightly at every single point in our familiar 3D space that we are completely unaware of their existence. The Google quantum team's discovery is like finding those almost invisible footprints of the ant on the garden hose. Footprints that perfectly match the predicted gait of an ant we'd only theorized about. The specific light distortions observed around certain galaxies in Pandora's cluster, particularly the way gravity seems to behave slightly off, could be interpreted as evidence of gravity leaking or interacting with these tiny, curled-up extra dimensions. It's as if the gravitational field isn't entirely confined to our 3D brain, a term from M-theory, an extension of string theory referring to our dimensional membrane, but can slosh over just a tiny bit into these hidden realms. This could be a monumental piece of the puzzle in explaining one of physics' most enduring mysteries. Why is gravity so astonishingly weak compared to the other fundamental forces? Think about it. You can overcome the gravitational pull of the entire Earth with a tiny refrigerator magnet lifting a paperclip. Electromagnetism, in that instance, is vastly stronger. If gravity is the only force that can propagate freely through all dimensions, while other forces are confined to our 3D brain, then its strength would be diluted as it spreads out into these larger, unseen spatial dimensions. This would make it appear weaker to us, confined as we are to our 3. The light patterns from Webb, analyzed by quantum minds, might just be the universe whispering, "There's more to me than meets your eye, and gravity knows the way." Let's really unpack what the existence of extra dimensions would mean, not just for physics, but for our conceptual understanding of everything. Imagine you're a flatlander, a two-dimensional being living on a perfectly flat plane, as described in Edwin Abbott's classic novel. Your entire universe is length and width. You have no concept of up or down. A three-dimensional being, like us, could look down upon your entire 2D universe, see everything within it, even reach in and touch any point. And you, the flatlander, would only perceive a cross-section of the 3D object appearing and disappearing mysteriously. You'd have no way to see the 3D being approaching or comprehend its true form. Now extrapolate that. We are 3D, plus time beings. If our 3D universe is merely a slice or a brain within a higher dimensional space, often called the bulk, there could be directions beyond our familiar up-down, left-right, forward-backward that we simply cannot perceive or interact with directly. Yet, these dimensions could profoundly influence our reality. This brings us to two of the biggest elephants in the cosmic room: dark matter and dark energy. Together, they are thought to constitute about 95% of the total mass energy content of the universe. Yet we can't see them, can't touch them, can't directly detect them. Dark matter's presence is inferred from its gravitational effects on visible matter. Galaxies rotate faster than they should. Galaxy clusters hold together when they should fly apart. Dark energy is the mysterious force causing the expansion of the universe to accelerate. What if these enigmatic components aren't matter or energy in the way we understand them within our 3 dimensions, but are instead manifestations of gravity interacting with these extra dimensions, or phenomena rooted entirely within those higher dimensions whose influence leaks into ours? They might be the shadows cast by higher dimensional physics onto our 3D cave wall. This isn't just wild speculation. Esteemed physicists like Dr. Lisa Randall at Harvard have explored models where extra dimensions might not be infinitesimally small and curled up. Some could be large, though still subatomic, or even infinite in extent. In her brain world scenarios, our universe is a 3D membrane embedded in a higher dimensional space. Gravity, being a property of space-time itself, could be weaker on our brain because it spreads out into the bulk. The subtle light distortions Webb detected could be precisely the kind of gravitational leakage her models predict. Like water, seeping through almost invisible cracks in a dam, subtly altering the flow on our side in measurable ways if you have the instruments and the analytical power to detect it. For you, this isn't just some abstract scientific daydream. It's a profound invitation to reconsider the nature of reality itself. Think about the limitations of your own perception. We see only a tiny fraction of the electromagnetic spectrum, visible light. We hear only a narrow range of sound frequencies. Our senses evolved to navigate our immediate terrestrial environment, not the full scope of cosmic reality. If there are physical dimensions we can't perceive, what about other kinds of dimensions in our lives? Consider the depths of human consciousness, the complex interplay of emotions, the unseen connections in relationships, the dreams and aspirations that shape our paths. How many of these subtle, yet powerful dimensions of your personal world do you overlook simply because they aren't as tangible as the chair you're sitting on? Just as scientists are developing new tools to probe hidden physical dimensions, we can cultivate introspection and empathy to explore the unseen yet deeply influential layers of our own human experience. What hidden potentials, what unacknowledged aspects of yourself are curled up in the corners of your mind, waiting for the right kind of light to be revealed? When news of Google's preliminary findings, backed by Webb's data, began to circulate, first through internal reviews, then through preprint servers, and finally into initial peer-reviewed publications, the scientific community didn't just buzz, it ignited. Imagine a dormant volcano suddenly showing signs of a massive eruption. That's the kind of energy. Teams at leading institutions like MIT, Caltech, Princeton, and CERN are now scrambling. Some are designing new algorithms to reanalyze Webb's existing data from Pandora's cluster and other deep field observations, looking for these specific anomalous signatures. Others are frantically writing proposals for more telescope time, not just on Webb, but on other powerful instruments like the European Southern Observatory's Very Large Telescope, VLT, in Chile, or the upcoming Extremely Large Telescope, ELT, to zoom in on these regions of interest with different observational techniques and wavelengths. The primary goal is crystal clear: verification, verification, verification. Are these patterns genuinely evidence of dimensional leakage, or could they be something else, an undiscovered instrumental artifact of Webb itself, a novel quantum phenomenon within our known dimensions, or perhaps an exotic, though conventional, astrophysical process we haven't yet modeled? This is science at its most exhilarating and its most rigorous. A hypothesis so audacious it threatens to overturn foundational paradigms is now being subjected to the fiercest scrutiny imaginable. The peer review process for papers related to this is being fast-tracked, not out of haste, but because the implications are too profound to delay. Think back to when Einstein first proposed general relativity. It challenged Newtonian physics to its core. This feels like one of those moments. If these findings hold, it's Nobel Prizes all around and a complete rewriting of physics textbooks. But let's inject a healthy dose of scientific realism. Skepticism is not just present, it's essential. Many brilliant scientists are rightly cautious. Some argue that what appears to be a dimensional signature could be a complex interplay of known physics in extreme environments, perhaps related to the distribution of dark matter within Pandora's cluster, interacting with the cosmic microwave background radiation in an unexpected way. Others raise concerns about the look elsewhere effect. When you search a vast dataset for anomalies, you're bound to find things that look strange just by chance. And of course, there's always the possibility of instrumental calibration. Issues, however, minute, that might mimic such signals when analyzed with ultra-sensitive quantum algorithms. This skepticism is the lifeblood of scientific progress. It forces proponents to strengthen their evidence, refine their models, and design more robust tests. Yet, even the most hardened skeptics admit that the consistency of these patterns across different areas within Pandora's cluster, and hints of similar anomalies in other deep field images, is deeply intriguing. It's like hearing a peculiar, unidentifiable musical motif woven into several distinct symphonies. It makes you lean in and listen harder, wondering about the composer's intent. So, why should you, amidst the hustle of daily life, care about telescopes peering into the cosmic dawn or quantum computers crunching unimaginable numbers? Because this isn't just an academic exercise. This is about our fundamental connection to the universe. The cosmos isn't a distant, cold, indifferent entity. It's our origin story, our home, our destiny. Every atom in your body was forged in the heart of a star, or in the Big Bang itself. You are, quite literally, stardust. Every discovery that deepens our understanding of the universe inherently deepens our understanding of ourselves and our place within this grand, unfolding narrative. Remember that feeling of looking up at a star-drenched sky? That blend of feeling infinitesimally small yet profoundly connected? That innate human curiosity, that yearning to comprehend the whole, is the same fire that drives scientists to chase these monumental questions. It's a thread that binds us all to this cosmic quest. Consider gravity, the force that anchors you to Earth, that dictates the dance of planets and galaxies. If its apparent weakness is indeed due to its seeping into extra dimensions, then those dimensions are not some abstract mathematical construct. They are an integral part of your everyday experience, subtly shaping the very forces that govern your existence. Think about dark energy, that enigmatic force pushing the universe apart. At an ever-increasing rate, if dark energy is intrinsically linked to the geometry of these hidden dimensions, then the ultimate fate of our galaxy, our solar system, and indeed all of existence, is being written in a higher dimensional language. This discovery doesn't just add a new chapter to physics. It invites you to see yourself as part of an impossibly intricate cosmic tapestry, woven with threads of reality you can't yet see but can begin, with awe and wonder, to imagine. In your own life, this is a powerful call to cultivate insatiable curiosity. Just as scientists are bravely probing the deepest unknowns of the cosmos, you can ask daring questions about your own world, your own beliefs, your own potential. What assumptions about yourself, about others, about life, do you hold inviolable? What if some of them are based on an incomplete, lower-dimensional perspective? What dimensions of your relationships, your career, your passions, or your spiritual life lie unexplored, waiting for you to shift your perspective and perceive them? The universe is relentlessly teaching us that reality is almost always deeper, stranger, and more magnificent than it appears on the surface. You can apply that lesson today in your own sphere of influence. Perhaps it's finally having that difficult but necessary conversation, or taking the first step towards a dream you've long deferred, or simply looking at a familiar situation with fresh, inquisitive eyes. The courage to explore the unknown, whether it's the fabric of space-time or the landscape of your own heart, is a universal human trait. What's the next chapter in this incredible cosmic adventure? The verification process is already in high gear, a global symphony of scientific effort. Scientists are not just reanalyzing old data. They're developing entirely new algorithms, specifically tuned to hunt for these dimensional signatures with even greater sensitivity. Sophisticated computer simulations are being run, modeling how light from distant quasars and galaxies would behave if it indeed traversed a higher dimensional space-time, trying to predict specific, falsifiable observational effects. New observation campaigns are being meticulously planned, targeting the most promising anomalous regions in Pandora's cluster and other galaxy clusters with unprecedented precision, using a battery of instruments across the electromagnetic spectrum. If these follow-up missions confirm the initial patterns, we could have independent corroborating results within a matter of months, or perhaps a year or two, a mere blink in the vast timeline of scientific discovery. The most thrilling prospect, the holy grail of this phase, is cross-verification. If the Very Large Telescope, or perhaps radio telescopes like the Square Kilometre Array, once fully operational, using entirely different technologies and looking at different aspects of these cosmic structures, detect congruent anomalies that point to the same conclusion. It's akin to multiple, independent, credible witnesses describing the same unbelievable event. The case for extra dimensions would transition from tantalizing speculation to compelling theory, verging on accepted fact. Simultaneously, theoretical physicists are experiencing a renaissance. Decades-old string theory models, often relegated to the fringes of testable science, are being dusted off, re-examined, and tweaked in light of this potential observational anchor. It's a frantic, exhilarating race to build a robust theoretical framework that can not only explain these specific light anomalies, but also elegantly incorporate them into a more complete theory of everything, one that finally reconciles the two pillars of modern physics: Einstein's general relativity, which describes gravity and the large-scale universe, and quantum mechanics, which describes the other forces and the subatomic realm. These two theories, while incredibly successful in their own domains, are famously incompatible. Extra dimensions might just be the bridge that unites them. This quest isn't just about validating a fascinating theory. It's about unlocking doors to understanding the universe's most profound secrets. If extra dimensions are real and accessible to gravity, they could finally explain the true nature of dark matter and dark energy, reveal the mechanics behind the universe's accelerating expansion, offer insights into what happens inside black holes, and perhaps even shed light on the very first moments after the Big Bang. For you and me, it's a stunning reminder that monumental breakthroughs often emerge from the unexpected synergy of different fields. In this case, cutting-edge telescopic observations and visionary quantum computation, teaming up to decode a message encrypted in the fabric of reality itself. So as we stand on the precipice of this potentially reality-altering revelation, what's the ultimate takeaway from this journey into the hidden dimensions of our universe? It's a profound lesson in humility and an invigorating call to boundless curiosity. For centuries, humanity has cyclically believed it was on the verge of figuring out reality, only to have the universe peel back another layer, revealing an even deeper, more intricate, and often far stranger truth. This potential discovery, whether it definitively confirms extra dimensions or leads us to an entirely new, unforeseen understanding, underscores a fundamental truth: the cosmos is always more wondrous and more mysterious than our current theories can contain. It's a cosmic invitation to remain open, to question relentlessly, and to explore with the heart of a child and the mind of a sage. In your own life, I urge you to embrace this spirit of the unknown. Is there a new skill you're hesitant to learn because it seems too daunting? A challenging conversation you've been avoiding out of fear of the outcome? A creative endeavor you've kept locked away? The universe doesn't shy away from its magnificent complexities and its profound mysteries, and neither should you. Take that first tentative step into your own uncharted territories. Ask that silly question. Look a little closer, a little deeper. You might just uncover dimensions of yourself, of your capabilities, and of your connection to the world that you never dreamed existed. What are your thoughts on all this? Could our reality be interwoven with unseen dimensions, subtly shaping your world, your choices, your very being right now? What mysteries in your own life, big or small, are beckoning you to explore them with fresh eyes and an open heart? I'd love to hear your reflections in the comments below. Let's keep this extraordinary cosmic conversation alive. And if you're as captivated and thrilled by the universe's unfolding secrets as I am, please hit that subscribe button and ring the notification bell. We have so many more exhilarating breakthroughs and cosmic riddles to explore together. From attempts to visualize these extra dimensions to the ongoing quest to decode the deepest language of existence.